Hi everyone, my name is Miss Connolly. I started making videos for my 5th grade students, and this one's for them, but I decided to make them public so we could get as many students learning during this crazy time as possible. So please make sure you like, subscribe, or share so we can get the word out that there's these math videos and everyone can be learning and getting ready for their next grade level. So let's talk about quadrilaterals. So this video is just to name the different attributes that we can talk about when we're describing quadrilaterals. We are not going to be classifying these shapes in this video. We're not going to be saying what's a rectangle, what's a square, any of that. We're just going to be talking about the attributes of shapes. So I'm going to make another video where we talk about the hierarchy of shapes and which shape fits in which category based on which attributes. But first, we need to know the attributes. So a quadrilateral, the word part quad means four, okay? So we're talking about all fours, all things fours. So quadrilaterals are polygons that have 4 sides, 4 angles, and 4 vertices. So what do I mean by polygon? A polygon is a shape with many sides, okay? We're going to be talking about specific polygons, quadrilaterals, 4 sides. And you'll notice that in a polygon, all sides are straight. All sides meet at a vertex and stop. They do not overlap and keep going. And they also don't have any open spaces, and there's no curved lines, okay? So we're going to be talking about quadrilaterals, which are polygons that have 4 sides, 4 angles, and 4 vertices. So what do we mean by sides? We mean 1, 2, 3, 4 sides, okay? So this is a side. What is a vertex? A vertex is where those sides meet. And vertices is the plural form of the word vertex. So we have 1, 2, 3, 4 vertices. And then the angle is the space inside where the 2 lines come together and we take the measurement, and that's the angle. Okay, so we have 1, 2, 3, 4 angles. Okay, so 4 angles, 4 vertices, and 4 sides. Okay, so all the shapes on this page that you see are quadrilaterals. All right, so let's look at even more quadrilaterals. We have all of these shapes that are quadrilaterals because they are polygons that have 4 sides, 4 shapes, 4 vertices. Now the rest is a lot of these that you're used to seeing, and this one over here, this purple one looks a little funky, but if you count the sides, 1, 2, 3, 4, it is still a quadrilateral, okay? So I just wanted to show you what they could look like many different ways, as long as they have 4 sides, 4 shapes, 4 vertices. So let's get into the attributes. All right, fair warning, I had a little trouble drawing on the screen, but the first attribute that we're going to talk about that we can use to describe quadrilaterals is parallel lines, okay? This won't be used to describe all quadrilaterals because you'll see in a minute that not all quadrilaterals have pairs of parallel lines, but a parallel line is a pair, parallel lines is a pair of lines that will never intersect. So, you know how 2 socks make 1 pair? Well, 2 lines make 1 pair of parallel lines. So here's our example down here. We have 2 lines that if we extend them forever in both directions, they will never meet. They will never intersect. So that is what we mean by parallel lines. And I'm going to go kind of quick through all this because it was learned in 4th grade. So I just want to make sure that you remember all of these words. So when we're thinking about parallel lines, in a quadrilateral, they're going to always be opposite of each other, okay? So a pair of parallel lines are opposite of each other, okay? So when you look at this rectangle here, we have the line on the top and the line on the bottom. If we extended them in both directions forever and ever and ever and ever, they will never intersect. So we say that that is 1 pair of parallel lines, okay? But when we look at the lines here on the left and on the right, if we extend both of those lines in both directions, they also will never meet. So that is our 2nd pair of parallel lines. So in this green rectangle up here, there's 2 pairs of parallel lines. Then down here in the shape labeled number 26, we have another set of parallel lines here. So see the green extended here? That's 1 pair of parallel lines. Okay, so they're going straight across the paper. 1 pair of parallel lines, they will never meet. Then, even though these lines are on a diagonal, I just wanted to show you this one example. Just because they're on a diagonal they can still be parallel, okay? Because if we extend them forever and ever and ever in one direction, they're never going to meet. And if we extend them forever and ever and ever in the other direction, they're never going to meet. So this is an example of another shape that has two pairs of parallel lines. Here and here are parallel to each other. So that's one pair of parallel lines. And then we have the top and the bottom parallel to each other. And they go on forever and will never meet. I should have drawn that going that way. Okay, so these are shapes that have two pairs of parallel lines. But we're not done there, because sometimes we might say a shape has 0 pairs of parallel lines. So I wanted you to see what that looks like. So this is where I had trouble drawing. But what's happening here is if I extended these lines, in green here you see, they will eventually meet. So what's happening is this line and this line are not parallel to each other because eventually they would meet out in space right here. Okay, so that set of lines is not parallel to each other. Then what I did here in black, I extended in this direction, which they would be getting further away from each other. But in this direction, they would end up meeting somewhere over here. And that is, again, not a pair of parallel lines because they end up meeting. So shape 15 here, again, not giving names to things as much as possible today, so I just want to explore attributes, has 0 pairs of parallel lines. There are no parallel lines, okay? But if we look at the one numbered 39, in blue here, you see if we extended the top line here and the bottom line, the lines that are opposite to each other, in both directions, that is one pair of parallel lines. And then these lines would end up meeting up here as you see. Okay, so that's not a pair of parallel lines. So with quadrilaterals, you can either say there are 0 pairs of parallel lines, like in this example. You can say that there might be 1 pair of parallel lines, like in this example, or you can say there's 2 pairs of parallel lines, like we saw in the last slide. So parallel lines, one attribute we can talk about. I just wanted to remind you of another set of lines that you might be familiar with, perpendicular lines. So perpendicular lines are lines that do intersect, okay? So they're not opposite from each other. We're going to be talking about the adjacent next to each other lines, and they intersect in a special way. They form a 90-degree angle, which is known as a right angle. Okay, so when these lines intersect, and this is the symbol that you see for a right angle when we're looking at shapes. Well, I'm not going to be able to use green. Okay, so when they intersect, these lines form a 90-degree angle, and that's known as perpendicular. So down here, if I extended these lines, they would also intersect to form a right angle. Down here, these ones intersect to form a right angle. And up here, they intersect to form a right angle. So just so you know what's out there, parallel lines never meet. Perpendicular lines, they intersect to form a right angle. Okay, so that's an important word when we're thinking about shapes, perpendicular. So speaking of angles, this is review from 4th grade. So it is going to go kind of fast, but I can make another video to help you remember with angles. So in 4th grade, you learned how to use a protractor, and you measured angles and you built angles. And it was really fun. Everyone has fun with the protractors. So what I want to point out to you is this word right angle means that you have a perfect 90-degree angle, okay? And you learned that the square corner of a piece of paper is a 90-degree angle, so you can use that to measure. And you might have also taken a square tile and put it into the angles to see how much space was in there. So when we see a right angle, like I was saying, you will see the square there to represent that it's a perfect 90-degree angle. Okay, so right angle, 90 degrees. That's when the perpendicular lines meet. Okay, now an acute angle up here is less than 90 degrees. So anything smaller than 90 degrees is, that's a little degree sign, is an acute angle. Okay, so what they're showing you here is we have this shape, and this is where the lines meet, and this is the space inside. If it was a full right angle, it would come out here. But you see that there is all of this extra space to make it 90 degrees that's not filled by the intersecting lines. Therefore, it's an acute angle. It's less than 90 degrees. There's all that extra space there. Okay? Now, next we have, last but not least, an obtuse angle, which I'm sure you guessed and remembered is greater than 90 degrees. Okay? Sometimes you might hear a teacher say it's an acute little angle, which means it's smaller than 90 degrees. That's a little way to remember the words. It's a cute little angle. So cute. So acute is less than 90 degrees. All right, so back to obtuse though. So obtuse, we're thinking about these lines here. And we see the piece of paper going in here, and this would be the 90 degrees. But you see that this line extends beyond where 90 degrees is, and you can see this extra space here. That means that it's greater than 90 degrees. I'll erase that so you can see the extra space. And it's an obtuse angle. So let's think about how we can use this when we're looking at shapes. Let's talk about angles. All right, so when I'm describing the attributes of shapes, you might be able to talk about parallel lines. Okay, I obviously see 4 sides, 4 angles, 4 vertices. But you can also now throw in what types of angles you see. So I'm only going to talk about angles with these shapes. At the end, I'm going to bring it all together. So if I am naming the angle sizes of these shapes, just don't want it to be blue, I will say that I see 4 right angles. Okay, so that is one way I could describe this shape. Many other ways, going to bring it all together at the end. In this shape here, I see 2 acute angles, and then I see 2 obtuse angles. And I'm doing that, well, trying to do that, to show that these angles are actually equal to each other. There's something to think about. We're not going to talk about it right now. But in this shape, I see 2 acute angles and 2 obtuse angles. Okay, so that's how I would use angles to describe a shape, to describe the attributes. In this shape, I see 2 right angles, 1 obtuse angle, and then 1 acute angle down here. All right, and then in this last shape, I would say I see 2 obtuse angles, and then I see 2 acute angles down here. Okay, so that's the way that I would use, that is the words that I would use to describe the shape. I'm going to put these in a different color so they're cute. That's the way I would describe what angles I'm seeing. So you can talk about 4 sides, 4 vertices, 4 angles. You can talk about the pairs of parallel lines, 0 pairs of parallel lines, 1 pair of parallel lines, 2 pairs of parallel lines. You can talk about right angles, acute angles, obtuse angles, but we're not done yet. What else can we talk about? Well, let's find out. All right, you can also talk about the lengths of the sides. All right, so a couple ways to talk about the lengths of the sides. When I look at this shape here, I notice that this side is equivalent, equal to this side, okay? But then I look at it a little closer and I notice that this side and this side are also the same length as the first 2 sides. So for this shape, when I'm talking about the length of the sides, I would say all 4 sides are equal, okay? So I'm not necessarily saying, oh, it's like 12 inches long. I'm not meaning that. I mean, if all the sides are the same length, you can talk about, okay? Over here, if I look again, I see that this side and this side are equal to each other. And then I'm like, well, this and this are also the same length. So in that shape, all 4 sides are equal as well. Okay, we can talk about the length of the sides, but that's not how we describe shapes usually. So we're going to be talking about if they have all 4 sides equal, so that's one option. Or you might say this side is equal to this side, but are they all equal? So I'm actually going to describe this by saying opposite sides are equal. Okay, and then I'll do 2 lines here to show that these 2 match. So in this shape, opposite sides are equal. And that's how I would talk about the length of the sides in that shape. And then this one's kind of done for you. So you see blue is equal to blue, so opposite sides are equal again, and then red is equal to red. So for these two shapes, I would say opposite sides are equal, different than all four sides being equal. Okay, and then when I come down here, you clearly see that no sides are equal. So that might be something you want to point out, is that you notice that none of the sides are equal to each other. All right, so let's bring it all together. This is where the exciting stuff comes in. So I have three shapes here. I'm going to model for you how I might describe the attributes of this shape. And then when we get into classifying shapes, this is really going to help us. So what do I notice about this shape here? Well, it stands out big time that all four sides are equal. So I'm going to talk about that. All four sides are equal to each other. It also stands out that there are four right angles. Okay, so I'll make sure that I talk about that. The other thing that I notice is that this line on top and this one are parallel to each other. So far I see one pair of parallel lines. And I notice that this line and this line are also parallel to each other. So I can say that there are two pairs of parallel lines. So just to repeat, for this one, I have four right angles. All four sides are equal, and I have two pairs of parallel lines. Okay, so that's how I would describe the attributes of this shape. You might also say there's four sides, four angles, four vertices, it's a quadrilateral, all those things, but let's dig a little bit deeper. I want you thinking about pairs of parallel lines, the size of the angles, and the size of the lengths of the sides, okay? All right, so let's look over here. And I notice that this line and this line are parallel to each other, okay? Then, so there's one pair of parallel lines so far. I notice that this line and this line, oops, you know what I mean, are also parallel to each other. So now I have two pairs of parallel lines. Okay, I'll erase all this because it's going to look confusing if I don't. So I have two pairs of parallel lines. All right. Then we talked about this shape in the screen about the length of sides. I noticed that this side and this side are equal to each other. And I notice that this side and this side are equal to each other. So I have two pairs of parallel lines, and I see that opposite sides are equal in length. Okay. Then I'm going to talk about the angles. I see an acute angle and an acute angle. So I have two acute angles so far. Then I'm going to see an obtuse angle and an obtuse angle. So when I'm describing the attributes of this shape, I'm going to say there's two pairs of parallel lines, opposite sides are equal, there's two acute angles and two obtuse angles. Okay? All right, last shape that I'm going to do, and then I'm going to have you choose from some that you want to do. All right, so when I look at this one, I'm thinking about this line, extending it forever, and this line, extending it forever. Okay, and you can do this in your head. I just want to show you what I'm talking about. I see one pair of parallel lines. Okay, I do not think that this is parallel because if I extended these lines, eventually they're going to run into each other. So those lines are not parallel to each other. There is only one pair of parallel lines. Then I see a right angle here and a right angle there. So I would say I see two right angles. I see one obtuse angle and I see one acute angle. So when I'm describing this shape, I would say there's one pair of parallel lines, two right angles, one obtuse angle, and one acute angle. And I don't notice that any of the sides are equal to each other. Okay? So what are you going to do at home? You are going to think about any of these shapes that you want to. You can pick all of them, you can pick two of them, pick three of them, but I want you to practice describing the attributes. And you are only going to be thinking about, well, not only, you want to make sure you also include How many pairs of parallel lines? What types of angles do you see? How many right angles do you see? Do you see 4? Do you see 0? Do you see 2? How many acute angles do you see? How many obtuse angles do you see? And then I want you thinking about the length of the sides. Are all 4 sides equal? Are opposite sides equal? Is there one set of opposite sides that are equal? Are 0 sides equal to each other? Those are the things that I want you thinking about when we are describing the attributes that we see when we're looking at quadrilaterals. This is going to help us classify them and give them a name. And we'll be thinking about, is a square a rectangle? Is a rectangle a square? It's all very confusing, but I'll make it clear for you. Okay, so make sure you practice those attributes. Bye.